All right, lesson 23, laws of logarithms. Okay, so this actually is on your formula sheet, by the way, too. Maybe I'll show that first. So on your formula sheet, you guys will see, well, you won't see all that, but you'll see these, right? Your laws of logarithms. So this will be a big part of this unit. So what'll happen is we just need to get used to writing logarithms in different ways. So, and how this works is in the same way that we had exponent laws that we've been going through ever since grade 9, really. We've got the same sort of thing that's for the same reason, actually, as we have log laws for the same reason that we have exponent laws. Okay, so the way this is going to work, this is your first log law, is it's saying log b. So it means like the log of anything. That could be log of 2, that could be log of like 4, that could be like anything there. That of any two numbers multiplied together can also be written as a split up version of that. Okay, so I'll kind of explain how that relates maybe to exponent laws here in a second, but let's just come up with an example and see how this works. So let's say we had log base 2 of 32. Okay, so another way of writing that, we could rewrite this for a second as log base 2 of, and I'm just going to split that up as 8 times 4, right? That's the same thing, but I'm just writing it out as something times something, right? Okay, so according to our log law, that's the same thing as saying log base 2 times 8, and then if we're multiplying, then it's going to be adding, right? So it'd be the same thing as adding log base 2 of 4. So they'd be the same thing. So now, if we look at this a little bit closer, then what this part is here, right? So we have to get good at this. What number is this? We could put it in our calculator, and that'd be fine. You get the right answer. But we need to start getting better at figuring out, just from looking at it, what number is that giving? So again, what we want to do is say, I could rewrite that as 2 to the power of something is equal to 8, right? That's another way of looking at that. So you should be able to look at that and say, okay, well, that must be 3, right? 2 to the power of 3 is equal to 8. So that means log base 2 of 8, that's really 3. And you can do the same thing here. And I'm saying 2 to the power of something is 4. Okay, well, that must be 2. Okay, so this is really saying 3 plus 2. Okay, well, to begin with here, log base 2 of 32, if you put that all in, that's 5, right? So if I just put that in my calculator, I would have got 5 to begin with. Well, this would be the same thing as saying like 2, right? 2 to the power of 3 plus 2 is equal to 32, right? Because this side of the equation, that's solving for exponents, right? This is saying that's what the exponent is, 3 plus 2. 3 plus 2 is 32. So that's where that comes from, right? Our log laws really are just our exponent laws, but just kind of written in a different way. If you found that confusing, like how they're like connected, don't worry too much about it. You just do need to be able to make sure that you're able to use our log laws on your formula sheet. But yeah, that's really the connection there, that it really is an exponent law. All right, so we had our product law was the first one. Now we have our quotient law. The same thing, really, but now we're saying if you're dividing, then you're going to be subtracting, right? Which I think is kind of intuitive, right? I kind of put dividing and subtracting in the same, usually it makes things smaller. I don't know, I find those as being similar. But okay, so if we had an example like log base 2 of 8 over 4, let's say. All right, well, according to our log law, then that would be written as log base 2 of 8, and then minus log base 2 of 4. Okay, well, what this is really saying, right? 2 to the power of what is 8? So that's 3, right? I can tell that without putting in my calculator. Same with this one. 2 to the power of what is 4? Well, the same as the last one, right? So that's 2 again. And I'm subtracting those. Well, that kind of makes sense, right? So in the end here, that's good. Like this is all saying log base 2 of 8 over 4 would be equal to 1. And like, or you could say it this way, that or log base, and if I actually just divided those, right? If I wrote that as log base 2 of 2 is equal to 1, I can see that that makes sense, right? That's saying 2 to the power of 1 is equal to 2, and that's true. That's a true statement, right? So yeah, that's how that one works. Now, power laws. So a power law, the way this one's going to work is that you can see, and this is my like mental trick that, or my yeah, like how I think of this is that if you've got this exponent up top on any log statement like this, you can bring that down to the front and make it a multiplication statement. So that's what this is, right? That n that was up here. Well, now it's just actually multiplied by the log in front of it. Okay, so if we had an example like this, if we had log base, we'll say b, doesn't matter, times x to the power of 5, that would be the same thing as just bringing that 5 down in the front. So that'd be the same thing as 5 times log base b of x. Okay. Now, other examples that are going to come up that we're going to do here in a second will be one like this as well. So if we had, let's say, log base b of the square root of x, well, we haven't talked about how to deal with like a square root, right? So that's why we're going to write that a little different. I'm going to write that instead as a log base b of, and then I want this to be an exponent because I know how to handle exponents. So I'm going to rewrite this as x to the power of a half, right? Remember how top number is like the exponent on that one, if that was a 3 or a 2 or something like that, and the bottom number is the root. So I'm just rewriting a square root as a half. And then now that it's written like that, I can just apply my power law. So bring that down out front. So that ends up being 1/2 log b of x. All right. And then our last one here is a change of base. And I really actually talked about this in one of the other lessons there too, but this looks confusing. But I think if I put numbers in here, it makes a bit more sense. Let's say if I had log base 2 of 3, right? What they're saying is that we could rewrite that. You get the same answer if we did this. If I would have said log base and then pick any other log, it could be log base like 10, like we do quite often. It could be log base 4, 5, any number. I'll do log base 10 because we do it so often. And then it's log base of the top number, log base 10 of 3, divided by log base 10 of 2. And they're saying that would just get you the same answer. And this is quite handy, especially if you have a like TI-83 calculator, because that calculator doesn't actually let you, type it in like this. If you go log, and then yours, I think, would have, a little space there and like another space, so you can put your numbers into those spots and then get the answer. Some calculators don't have that, so it actually forces you to write it out like this. So it's not that big a deal, though. It's not like it doesn't take too long to do that either. But okay, so there's our log laws. So let's put them into practice here. So first one, this wants us to expand each expression. So what we're going to do here is we're going to write this out, where all these things are multiplied right now. Let's go back up just for a second. I'm going to write them out more like this, right? I should be seeing like this or like this, right? I should be seeing some addition and subtraction happening here. Okay. So here's how we're going to do it. So it's always going to be log base 4. So it's going to be log base 4 for this expression, I mean. So log base 4 of, and then if it's on the top, this is a good way to remember it. If it's on the top, it's going to be positive in our statement. So here's what I mean by that. So log base 4 of x to the power of 3. And then so that'd be like positive because it's on the top, but we don't need to write the positive out front. And then the y is on the top as well. It's in the numerator. So that's going to be plus log base 4 of y. And then the 4 is in the denominator. So that's going to be minus log base 4 of 4. And then the z is also in the denominator. So it's going to be minus log base 4 of z. Now, you would want to clean it up if you can. There's a couple things we can change here. I can also apply another log law here. I'm not going to leave my exponent sitting on the x there. I can apply that to it, right? You can bring it down front. So that was our third log law there, right? That was our power law. So I'll bring that out front. So we've got 3 log base 4 of x plus, and I can't really do anything with this. That's as simple as we can go. So log base 4 of y. But then this one I actually can. You might not see it at first, but whenever you have something that's all numbers, right? I don't have an x or a y in there. That's a number, right? Like this could be written, this could be put in my calculator, and I'd actually get a number out of that. But I actually don't even have to put my calculator because I can see from this one, this is a statement. This is saying 4 to the power of what is equal to 4. So you should be able to do this when you're ahead. 4 to the power of 1 is equal to 4, right? So all of that is just the same thing as 1. Okay, and then I can't do anything with this. So this is still just log base 4 of z. So there you go. There's your expanded form of that expression. Okay, so let's do another one. So here, I'll do a different color so I don't get confused here. So we'll say log base 5 of, and then again, so I've got that square root happening, right? I don't like square roots when we're doing this. I'd rather this be written as an exponent. So let's just do that for our first step here. We'll rewrite this whole thing as in brackets, x to the power, or x times y to the power of 3. And then we're going to change that to the power of a half. Okay. And now I'm going to rewrite that as, well, we're going to have to remember some exponent laws here too, right? From, grade 9 and all the grades till now. If you have a power to a power, what do? It's you multiply, right? A power to a power, you multiply. So this expression, if I just apply that half to both those things, this would become log base 5 of x to the power of a half, right? That's like x to the power of 1 times a half, that's a half. And then y to the power of, and then 3 times a half, that's 3 over 2. Okay, now let's carry on up here. I'm now going to rewrite this, right? This is a multiplication statement. So I can apply my log law to that. I'm going to write that out a little different. So we're going to say, well, that is the same thing as log base 5 of x to the power of a half plus, because I'm multiplying, right? Plus log base 5 of y to the power of 3 over 2. Now, technically, I should get rid of those exponents, right? I'm going to bring that one down like we did in the last one and that one down like we did in the last one. So this would actually be 1/2 log base 5 of x plus 3 over 2 log base 5 of y. Maybe we'll circle it. I'm getting a little bit messy here. Okay, so that'd be my expanded form of that, okay? All right, next one. So we'll do, again, I'm going to try to see if I can write this without having that radical in there. So this will be log of 100. Oh, and notice too that this one doesn't have anything on it, right? It's just log. These ones are base 5 and base 4. It doesn't have anything on it. Remember what that means. That's really log base 10. But that one's so common that we just write it as log, right? So log of 100. And then I'm going to rewrite all of that as, here, I'll put this in brackets so I know what I'm doing here. So that's going to be times, and then x to the power of 4 over 3. That's how you write that exponent. Hopefully that looks right. And then over, and then y, I'll leave it as y to the power of 2 for a second. All right, so now what is that equal to? Okay, so that's going to be, well, log of 100, right? And I don't even need the base because it's really base 10, plus, and then this is, I'm going to do this in one move. This is 4 over 3 log of x, right? I just moved the, I turned it in. It would have been log of x to the power of 4 over 3, but I moved the 4 over 3 down in one step there. You guys will start getting good at that as you go. Okay, and then the y squared is in the denominator, so that's going to be minus. So there'll be minus, and then same thing. I'm going to call that 2 log y. Okay. And then that's pretty good, other than, again, I'm just looking at a number there. That's not even going to be, there's no variable in there. So what would this equal? Remember, this is really log base 10, right? So this is saying 10 to the power of what is 100? Okay, well, that's 2, right? 10 to the power of 2 is 100. So plus 4 over 3 log x minus 2 log y. All right, and that's our simplified form, or expanded form, I should say. All right, now we're going to go the other way. So just everything in reverse, really, right? So now in this one, they want us to rewrite this as a simplified, like, single logarithms. Okay, and it also says answer should be written with positive exponents. Okay, all right. So what that means is that if you have negative exponent, you'd flip it, right? Negative exponents like flip things around, so you'd write it on the top or write it on the bottom, right? But all right, so how are we going to do this? This will be log, and they're all base 2, so I know it's going to be log base 2 of, and then, okay, what's happening here? I'm subtracting and I'm subtracting. Those subtracting, those, yeah, subtraction statements mean that these guys, right, everything that's happening because of that, that's going to be in the denominator, right? And this one is technically like positive, so that's going to be up in the numerator. All right, so that will be up in the numerator. So that's going to be x to the power of 3. And then my denominator, I should have, well, are you guys okay if I do this right now? This 4 is going to like move up to the x, right? It's going to be like x to the power of 4. It could be written that way. So we're going to write this as x to the power of 4. And then, maybe for a second, I'm just so I don't get confused, I'm going to write this as square root of x. All right, now let's just simplify this a bit. This would be the same thing as log base 2 of, and here, let's simplify that out, right? You subtract exponents when you're dividing, so that would be the same thing as 1 over x to the power of 1, and then times square root of x. Now, that's pretty much it, but again, we can rewrite that square root a little different. Actually, you know what? I'm going to write it a little different right now. Sorry if that screwed you up. I'm going to write that as x to the power of a half, right? That's the same thing as square root of x. All right, and then that is equal to log base 2 of 1 over, and then remember what we do when you multiply, right? We're multiplying these down in the denominator. You add the exponents, okay? So that's going to be the same thing as 1 plus a half. So that's going to be x to the power of 3 over 2. All right, moving on. All right, so this will be log. Oh, okay. This will be the same thing as log base 6, right? They're all base 6 there, so we're good there. And then this will be on the top, this will be on the top, and this will be on the bottom, right? So those are positive, and that's negative, okay? So the first one, this is going to be, I'm going to write it all at once. I think we're going to a little bit better maybe. So this is log base 6 of y squared, and that really would be to the power of 4 as well, right? And what's happening there is I moved that 4 up to the top when I did that, right? Okay, so that's 2 to the power of 4, or sorry, y squared to the power of 4 times, and then this one is just y, right? That one there. And then on the bottom, because we're subtracting, that would be the same thing as y to the power of 2 over 3. Okay, and then just simplifying this guy up, we'd have log base 6 of y to the power of 9, right? If I multiply those and then add the 1, so y to the power of 9 over y to the power of 2 over 3. And then that's equal to log base 6 of, and then remember what you do here, 9 minus 2 over 3. So you can do that in your calculator. That's fine if you want to, or you need common denominators there, right, to do that. But that would be of y to the power of 25 over 3. Oh, this one won't take too long. So log of x minus 3 and log of x plus 4, and we are adding. So as a single logarithm, this thing can be written like this. It'd be log, base 10 really, but log of, and then here, I'm going to write this with a square bracket for a second, just so I can see what I'm doing here. And then that would be of x minus 3, and then since we're adding, it's going to be multiplied by x plus 4. And then you could expand all that out too, right? So this would be the same thing as log of, and then expanding that, you get x squared plus x minus 12. All right, moving on. All right, this is a weird one. So it says evaluate each expression. So we can do this. We can do a lot of it without calculators. I'll probably use a bit of calculator more in that one. We don't even really need it for the first one here. So just for a second here, let's just kind of think about what this is saying. Log of 1. So remember what that means. That's really log base 10 of 1. Okay, so that's saying 10 to the power of something is 1. All right, so remember how something like anything to the power of 0 is 1? So that's that tricky little guy there, right? Where that would be 0, right? Log of 1, that is equal to 0. So I've got 0 minus, and now this guy. We can simplify this guy out a bit. Now, this is kind of a weird one, and this comes up a lot. This is probably worth me talking a bit about. If you've got 10 to the power of log, and this is really log base 10 of anything, right? Let's say it was x or anything, right? What happens here is that you've got 10 as an exponent, you've got log base 10. These guys are exactly opposite of each other. I'm going 10 to the power of log 10. That's almost like saying that you are like multiplying by 4 and then you're dividing by 4. These are really like inverse operations of each other. So what happens there, you can kind of think about it this way. These guys end up almost like canceling. They cancel with each other, and you just end up with x. You'd end up with whatever it was. Like in this case, it was log of 1,000. So that would just be 1,000. Okay. So we're going to start using that quite a lot more coming up here too. But yeah, just for now, that's a handy little thing, right? So it'd be the same thing, just so you're aware. If we had like 4 to the power of log base 4 of, I don't know, 17. Okay, well, that would just be 17, right? You can think about these guys as like canceling with each other. All right, so let's keep going. That was 0, and then minus, and this would just be 1,000, right? Those cancel with each other. So we got 1,000. And we've got the next one here. So 1/2 of this. Okay, so I'm going to go like reverse here, where I'm going to put this back up top. So I've really got like 100 to the power of 1/2. Okay, well, that's actually the same thing as log of 100 to 1/2. That's the same as square root of 100. Okay, and then the last one here, let's say, okay, minus, and I think this might be a little easier too. Well, and one thing too, guys, I wrote this out. I'm coming up with like, ways to figure these things kind of out in my head. It would have worked as well too if we would have said, okay, what is log base 10 of 100? So that'd be like 10 to the power of what is 100? That'd be 2. That might even be a better way than what I'm doing here. But there's multiple ways to do these, right? So we could have said, okay, that's 2, and then 1/2 times 2. So that's going to be 1. But I'll show you that the way I'm doing it here will also give me the same answer. So there's more than one way to do this. This is kind of what I'm saying. Anyway, so now I'm going to bring this 2 down front, I think. So I'm going to rewrite this as 2, and then log of, and then I can rewrite this guy, that like 0.00001. That can be rewritten as 10 to the power of -5. Okay, so then that, here, I'm going to write this all out again. 0 minus 1,000, and then plus, and let's do this one while we're at it. What is the square root of 100? Well, that's 10, right? So that's log base 10. Log base 10 of 10. Okay, log base 10 of 10, that's 1, right? 10 to the power of 1 is 10. Okay, so that's going to be 1 here. And then minus, and then what I'm going to do here, I'm going to bring this -5 down out front. So this will be minus, and then so far I've got, I'll put a bracket there to distinguish the negatives here. minus 10, right? Negative 5 times 2 times log 10. Okay. Now, again here, this part right here, 10 to the power, or log base 10 of 10, well, that's 1. So let's simplify this again. 0 minus 1,000 plus, well, that was just 1, right, for that one. And then minus, and that was just 1. So this is like minus negative 10. That's really like plus 10. So I'll just write that like now. Hopefully that made sense. Plus 10. Okay. And if you put all that in, right, like we can all do this without a calculator even. This would be the same thing as negative 989. Okay. You know what, guys? I think for the sake of time, I'm not going to do this one because actually this one, I end up putting numbers like into my calculator anyway while I do it. Yeah, I'm going to skip that one because I think we kind of did a bunch there. I think I'm going to spend my time doing this next one here. Okay. Given that, and sorry, before we get doing this one, guys, this is a very typical diploma question. There's always questions like this one, and here I'm going to read it out and give you like a little idea how this is gonna look. So it says, given that log base 5 of 6 is equal to A, and log base 5 of 7 is equal to B, and log base 5 of 8 is equal to C, it says rewrite the following logarithm in terms of A, B, C. So what this is, they've given us some log statement, and then they've given us really what these are. I almost think of them as like a key, right? They've given us that log base 5 of 6 is A, and log base 5 of 7 is B, right? These are like the key to my problem, right? So what I'm after here, right? Because they want us to write this in terms of A, B, and C, is I wanna like, manipulate this thing in such a way where I'm going to end up seeing a log base 5 of 6 in there. You know what I mean? Because what's going to happen there is if I can find myself a log base 5 of 6 in this expression by just rearranging it somehow, then I'm going to just get to replace that with an A, right? And I'm going to do the same with log base 5 of 7 and log base 5 of 8, right? So I'm going to see if I can find those numbers in here. Okay. So what I'm going to do is I'm going to rewrite this as log base 5, and I want that 30, right? I'd really like that 30 to either be like a 6, a 7, or an 8. Those are kind of the numbers I want to find out of this, right? So I'm going to rewrite that as instead of 30, I'm going to call that 6 times 5. So you might do a bit of like, trial and error in here, trying to find the numbers that multiply to that, right? But this is a good sign because 6 and, well, the 5 won't make any sense yet, but we'll see if we can make sense of that in a minute. Okay, so 6 and 5. And then the 56, I'm going to rewrite that as 7 and 8. And there we go, 7 and 8. And maybe this doesn't make sense yet, but watch what happens if we expand this thing now. So now if I rewrite this with my log laws again to expand things, this could be the same as log base 5 of, and then this would be log base 5 of 6. Hey, that's a good sign, right? Log base 5 of 6. I was looking for that. And it's that plus log base 5 of 5. Now, this one didn't show up, but I'll show you what to do with that in a second. So log base 5 of 5. And then these two are in the bottom, right? They're in the denominator. So they get a subtraction. So they'll be minus log base 5 of 7. Hey, look at that. Log base 5 of 7, right? That's the same thing as B. And then again, minus because it's in the denominator. Log base 5 of 8. And again, log base 5 of 8. That's a good sign. Okay, now let's turn this into, now we have everything like written the right way. Now we're going to use our key. Log base 5 of 6. Well, that's the same thing as A, right? They told us that that's equal to A. Okay, so that'll be A. And then log base 5 of 5, I don't have a key for that, but that's up to us to know what that is, right? This is all numbers. There's no variable. So I guess they all are, but we don't have a key for this one. But I actually know what this one is, right? This isn't going to be a decimal. This one's going to be nice. This is saying 5 to the power of something is 5. So all of that, that's 1, right? That's all equal to 1. And then minus Okay, and then log base 5 of 7, well, that's B. So that's B, and then log base 5 of 8, well, that's C, so minus C. And there you go. There is our answer written in terms of A, B, and C, right? Okay. So yeah, you guys actually will have a couple, like on your assessment there, you're gonna have a couple questions like this. Like I said, it's a very common one. So make sure you kind of figure out the pattern in doing these ones, because they look super confusing when you look at it, but it's not too bad when you break it down. So all right, so that's it, guys.